Welcome to another edition of the Sim Racing Garage. I'm Barry Rowland. In this episode, we'll be reviewing the new direct drive force feedback solution from the guys at Thrustmaster, the T818. With an all-new quick-release system, 10 newton meters of what Thrustmaster calls constant torque, could this be a good upgrade path for current Thrustmaster users and new sim racers looking to get into the direct drive solutions? Time to put it through the SRG's review process and see how it does. So, let's get to it. Let's take a closer look at this T818 from Thrustmaster. This is their first offering as far as a direct drive wheelbase is concerned. Out of the box, it presents as a mixture of plastic and metal. All of these parts here on the front and the back of the casements are injection molded plastics. And we have some venting here on the top that's injection molded plastic, along with the exact same piece on each side down towards the bottom, as you can see here. And of course, on the other side of the bottom, we have the same thing. I don't know if there's a fan in here or not, but with this setup, if there's not, then it would be a convection type cooling process where the heat would come out the top vents and the cooler air would come in on these bottom vents here. We'll see more about that once we get to our look inside segment. So the metal plates are replaceable with other colored plates that are available as accessories. Apparently, it's just 4 screws and they come off on both sides. So it does have some heft to it. It comes in at 12 pounds or around 12 pounds. And that's about 5.5 kilos for everybody else in the world. So it definitely has some heft to it. And at 10 newton meters claimed torque. Now, one thing about this 10 newton meters, while we're talking about that, they're calling it 10 newton meters as far as a constant force. Now, all servo motors have a constant rating on their newton meters as far as how much torque they put out. But we normally talk about direct drive wheels in the peak newton meters that they put out, because that's where we're going to get the spikes, like when you hit curbing and things like that, or you crash. What's the peak newton meters that this thing can put out? It's always more than the constant. So this thing will put out more than 10 newton meters, I guess is what I'm trying to say, if that indeed is a 10 newton meter constant on it. And I don't think I'm ever going to get an answer as far as what the peak is on this, but maybe someday we will. But right now we're just going to have to go with a 10 newton meter constant. It's just the way that Thrustmaster is presenting it as far as the information that's going to be available. The buttons on the side here, this is for navigating certain functions. We have a mode button here that has an LED. I guess it's going to tell us by color what kind of mode we're in. We have some selector buttons here. And then we have a stop force feedback button. Get a little closer look at that. Now the stop force feedback button, from what I've read, is supposed to stop the force feedback but not shut the motor down. So in other words, if you press this button, all the force feedback will be shunted. You'll still have a wheel that works, but you just won't have force feedback. The button is on the side, so if you're running a steering wheel, I'm not sure how convenient that's going to be. If your steering wheel takes off on you, you're going to have to let go of the wheel, obviously, or try to control the wheel until you can safely remove your hands from the wheel if it's spinning around. Then you're going to have to come around the side and hit this. I would prefer to have seen something like a remote button like we see on a lot of other types of solutions when it comes to direct drive feedback wheels. That way you don't have to get close to the wheel, you can just hit your button. But there it is. That's the way they're doing it now. What else can we talk about here? The back interfaces, we have a power button back here, and this is either on or off. And when it's on, it's recessed down into the housing a little bit there. When it's off, it sticks out more. So it will show you that if it's on or off by the position that it's in. We have a, well, it looks like a proprietary plug here for their power supply. We'll look at this power supply in a minute. USB-C is going to the PC. We also have an RJ45 plug right here. And that's for future accessories that Thrustmaster is going to be offering. We have the RJ12 proprietary shaped plug here, and that is a 6-pin. And then on the bottom here, this big hole here is, they don't have a plug in here yet. You can see there are some solder pads on the circuit board there. So I imagine that's where they'll be attaching whatever plug they're going to attach in the future for some other accessories or feature sets that Thrustmaster is going to be coming up with in the future. Now that piece here is not open like that when you get your wheel. There's actually a cap in it that I removed that keeps that covered up. So what else can we talk about by just looking at this wheel? We have an LED on the front, and it goes all the way around. You see a little plastic piece there right under the plastic bezel here that's silver. And of course, if you've noticed, there's a different quick release system on this wheelbase. And this is what Thrustmaster will be using going forward. And it's a cam lock system. And I'm not going to get into it too much right now because we're going to get into the adapters and using the wheels that you have now and so forth and so on later on in the review. And we'll get into a different segment for that because there's a few things I want to cover. But now the latch is made of an aluminum, and the rest of the assembly is a very stiff fiber reinforced nylon material, which is what you would want instead of regular type of injection molded plastic when it comes to using these higher torque direct drive motors. The bottom is where the mount is, and you can see we have 4 holes here. Now these are metal pieces. I haven't taken this apart yet for the look inside, so I don't know how they're oriented as far as how they're connected to the motor itself, but we'll get to that part when we get there. But this is solid steel, and it's been of course drilled and tapped for some holes. These are M6 bolts that go in here. And also on the bottom you can see there is a T818 designation here with a -16. And I'm not sure what that 16 means. Maybe this is the 16th wheelbase. Maybe that's the peak Newton meters. So disregard any of that stuff because I have no idea. I'm just kind of speculating here what that's for. But yeah, the 1816. But that's the only labeling that is on this unit here. I believe when you get a retail unit, there'll be other stickers on here and other identification things that have to be on there as far as the model numbers and things. We'll have to wait till they come out to take a look at that. Mounting is a direct mount. And by the way, this mounting hole, let's go ahead and turn this back over. Pattern is a whole new pattern for Thrustmaster. It's a proprietary pattern. It's 79 millimeters on the length, and it's 63, I believe, on the width. So that means I'll be drilling new holes in my deck. I have a 10 millimeter thick aluminum deck for my rig, and I'll be having to drill this whole pattern in there, but we'll talk more about that once we get to the mounting segment. And they do make a desk clamp adapter for this, and they also make a conversion that is able to mount a plate on top of this that has slots or holes on the side of it that will fit the normal Thrustmaster pattern according to what I'm reading. So that's kind of an adapter, if you will, that will convert this new proprietary setup out to something that you can use you already have maybe on a wheel deck that you might have on your rig. Yeah. Other than that, yeah, there's not much else to cover here. We'll go take a quick look at what comes with it. This power supply comes with it. Switching power supply, so it's good for North America or Europe, Asia. And it's putting out 24 volts at 7 amps, which also can tell us a little bit about what kind of power this thing can put out. And that comes out to about 168 watts. I don't know if that's peak or constant, but there it is. And it has, again, this proprietary plug on the end of it that will be plugging into that hole that you saw on the other side here. We get a cable, a normal cable like on a computer cable here, and this one has a North American plug on it for 115 volt. And if you live in Europe or somewhere else, you'll get that particular end or termination for yours, but you'll probably have the same power supply. The USB cable that comes with it is USB-C, and of course the USB-A to connect to your PC. Not sure how long this is. It looks to be about 2 meters just by the folded length of it. So hopefully this will have a good enough reach for everybody out there when you're trying to get to your PC. The wheel adapter, and we'll look closer at this in a minute or in another segment. You can see this has the threads in here that would be like it was sitting on another wheelbase for Thrustmaster, and we put our steering wheel in here with its threaded base, which is plastic, into here and threaded on like you normally would. And of course we have the locking screw that's still there. This is a very stiff fiber reinforced nylon material. And we also have this piece here that will be the adapter part. This part goes against the actual steering wheel, and then it will convert it to this. But again, I'll get into some more detail on our next segment when we start talking about the adapter and how we're going to be attaching existing wheels and what they're doing about future steering wheels. So that's it for the closer look. Not much really to see here. It's a compact little package Again, we've got some plastic and metal mixed in here. So yeah, I'm not sure why we didn't have metal all over. I would rather see that, but it is what it is when it comes to these kind of products. And yeah, what we'll do next is go ahead and get to the next segment. Now let's talk about the new quick release system that moving forward, Thrustmaster will be using on all of its wheels and bases. First off, the piece here that is attached to the motor shaft has a metal cam locking mechanism in it. And this is not metal. It's some kind of very stiff plastic, maybe some kind of fiber impregnated or reinforced type of plastic. Hard for me to tell, but we'll look at the collar over there and we can see it a little better. Inside you will see that there are, let's keep this open here so you guys can see what's going on with the pin situation. There's 6 pins in this. You see them right there. Now those are fixed pins, they're not spring loaded. And of course they're attached to a circuit board right there for electrical and data transmission. And the cam itself, let me get another grip on this, thing's kind of heavy. As you close it, the cam will come in on one side and the other. You can see the one on the bottom comes in first, and it has a piece of plastic on it. Let's go ahead and close it all the way. You can see the other cam will come in after that one does. And it kind of, I'm guessing that plastic piece in there does some kind of a location. Once you finally get it in, it squeezes it in because it definitely holds it quite tightly. So I'm going to get you a better look at that, I think. There you go. See that? It looks like a T sitting on top of the steel. This looks like to be cast aluminum as far as the metal there. And we're riding on 2 aluminum pins. So easy enough to operate. And this would be straight up and down for the wheel orientation, the way this looks. At least that's the way it ended up for me when I was doing some testing on it. So you just insert this piece. Obviously shaped the same way. And the pins on this side are actually spring loaded. So we can push these down a little bit. I don't know if you guys can see that very well. There you go. And of course, they're going to mate with the pins that are on the other side here. This is made of plastic. I'm not sure what kind of plastic this is. It's pretty tough stuff. I believe this is the same plastic that's used on the collar here. Using it on the collar, first I thought this was cast aluminum. That's how stiff this stuff is. And the way it handles and feels and even sounds. If you tap on this, get a little metal tweezers here. That does not sound like plastic, does it? But it certainly is. It's a very, very stiff material. And I even had to take a razor blade. I forget where I did it, but I shaved a little bit of it off just to make sure there wasn't aluminum underneath it or something, because of the way it sounds and feels. And they have this coarse screw that goes into the collar, just like on the collars on this TSPC back here and other wheelbases from Thrustmaster. And normally the screw is pretty easy to screw in, but it was very tough. I went ahead and put a screwdriver on it and tried to put it all the way in, and I took it back out. But you can see it's so stiff, this plastic is, that it actually removed the black oxide coating on the screw from the process of screwing it in and tapping in the threads from the screw into this plastic. So this is very stiff stuff. Some kind of fiber impregnation. You can see these slots on the back here. I was so curious about this because Thrustmaster had no answer for me. So I guess there is a proprietary material or whatever. But I did put this under my electronics microscope. I'll show you a shot of that here. And you can see the fibers in it, in these little indentations here that are on the back of this collar. So, stiff stuff. I mean, it sounds like metal to me. So I had to, again, shave it with a razor, take a razor and shave it a little bit, just to make sure that it was plastic. Now, on this side of it, we have the normal connector that we see in all of the Thrustmaster wheelbases, like this guy back here. Let me pull this up here. And by the way, the collar on this, get you out of the way, doesn't feel anything like this collar does. I mean, this one feels like plastic as soon as you grab it. Anybody's ever had a Thrustmaster wheelbase, you know what I'm talking about. You know, you just know it's plastic as soon as you put your hand on it. And not only that, but when you put the locking screw in, they strip out and you have to make a new hole for the locking screw. And they strip out pretty easily, actually, from my experience. So this is definitely a totally different material they've gone to than this. But you can see this is the same pattern that's on the regular Thrustmaster wheelbases. So this is going to be the converter. Now remember, the wheels moving forward for Thrustmaster are going to have this interface on them in here. I imagine they're going to have the same kind of plastic collar here, this very stiff material in place of this one here. You have to wait and see though, once they actually ship some wheels that have this on it. So pretty simple what we're going to do here for the adapter. Of course, this is the way they make it backwards compatible for all the other wheels that you have or you may have from Thrustmaster. What you do is you take this, and remember, they always have this very wide lug, and then we have 3 of the same size lugs around the other side. And this keys in so we don't get it messed up, and we get our plug that's inside of there located properly. So the same thing will happen here. We're going to plug this in, and the widest plug is on the top, and that's what we would do. We take this and put it in like so. And it only goes in, let's do it again this way. At first it'll only go in so far, like that. It will actually go in further, and I'll show you that in a second here, because there's no way, obviously, this plug is making good contact with the plug that's inside of our hub here. But first, that's what we do. Pretty simple, snug it up like that. Then we're going to come back with this collar, and it would be just like, obviously, the collar is back here. And we're going to put it in this way and screw it on, like so. And you want to screw this down to where it mates to the flange on the back of the wheel itself, whichever wheel you have. I'm going to go ahead and screw this down. See if I can get it far enough. It's very stiff, it's tough, it's not easy. In fact, I'm going to go ahead and pull this screw back out. I mean, it's pretty tight. Just trying to get it to seat all the way down. And it's not going very easily. So what I'm going to do is what I always do when I have something, a collar or something like that, and I need to tighten it down. I just can't get the grip I need on it, or I can't get it far enough with the strength of my hand. And what I'm going to use is just this strap wrench. You can use it for oil filters and all kinds of things, actually. Even cans of vegetables or something that you want to open and you can't. So anyway, you got to get your arrow correct. You see my arrow direction is that way, so we're going in a clockwise in relation to where our video is looking at. So I'll go ahead and snug this up by slipping this over here. And then I'll see if I can turn it far enough. Remember, I want to get it as flush as I can with the back part in there, right? It's not quite flush yet. You can see the gap there. So I'll go ahead and do this, see how far. I don't want to break anything either, so I'm kind of feeling it out. I don't want to go too far. I don't want to cause any problems, but I want to make sure that this plug, do it a little bit further. I think that's it. I'm not going to force it any further. Go ahead and put this over here. Yeah, and that looks a lot better. I think that's about as flush as I'm going to get. And I'm pretty confident that this insert has gone further enough down on the plug that's inside of here that I've got a good connection. Of course, there's only one way to find out, and that's put it on the wheelbase and turn things on. Now, of course, to put it on the wheelbase, to be honest, I don't think I'm even going to try to use this locking screw because this went on so tight. There's no way I'm getting this off with my hand. I don't think, yeah, this is not going to happen. I have to get the strap wrench back out. So I'm going to leave it without the screw. If I have any problems while I'm using it, then I'll just put the screw in, right? So now, simple matter of, just like most quick releases out in the world, I'm trying to make sure I got clearance here. I don't know, I might be able to do it this way. Then you can see that the orientation for straight up and down is like this, with the curved piece off to the side here. In this case, it's going to be on your left. I would think that it would have been like this because it would have looked better. To me anyway. But anyway, that's the way it goes on, because you can see that latch is going to come down straight down. Does it really matter? I don't think it does, as long as everything lines up internally. So we're going to loosen our cam up like this, and we'll just go ahead and slide this in. I think I can get it in there, yeah, without hitting the bottom of my bench here. and we just slide it in. Now once it's slid in, you can see it's still flopping around. But as we close down with the cam here and lock down on it, I think that's got it all the way. Yeah, you want to make sure you get it all the way down. Squeeze it pretty good, and there you have it. So this is definitely going to be a better quick release system than we've had before from Thrustmaster. Because it's made of this stiff plastic, you know, it's not going to be stiff as metal. And I'm all about stiffness when it comes to direct drive force feedback wheels. If you guys watch any of my videos, you know that's true. But yeah, I'm thinking this is going to be pretty stiff. And not only that, but this particular wheel, the SF1000, it has an aluminum insert into an aluminum backing. I believe this is plastic. But it has an aluminum insert in there for strength. And if you saw the review on this wheel, you know that this aluminum piece here has a spider attached to it internally to the steering wheel. So it's all one piece. So that makes it stiffer here on this particular wheel. What I'm saying is it's going to feel stiffer than if I had this wheel. And this is the Ferrari wheel from Thrustmaster. But you can see that it's a different plastic on the back here, number one. Number two is this is actually attached to the plastic. And there's some bolts on the other side, obviously holding this together, but it's all plastic on plastic. So at least on the SF1000, we've got that aluminum insert and the spider that's going through there. So it should give us a stiffer experience and give us the most feedback that we can get out of this kind of system. So this is what it's going to be. Yes, it is plastic. So something to consider. I don't know how it's going to react when we're actually using it, but it feels, you know, I'm getting some flex here. I don't think the flex is in the shaft, but then again, this is not a good test. We're going to have to get it mounted on my wheel deck over there. Once we have that bolted down with the 4 M6 bolts, then we'll be able to tell what kind of flex we have in this connection. And remember, any flex acts as a damper as far as the detail of the force feedback coming out of the motor that's in your direct drive wheelbase, whichever one you may have. So that's why it's important to have as stiff as you can get it, as far as getting as much detail realized out of this motor as you can. All right, so there's the connection. Again, all wheels moving forward. I'm going to go ahead and flip this up, see how easy it is, or not easy, to get it out. Of course, this is just the first time I've done this, so I imagine after a few times you do this, things are going to loosen up a little bit as far as the clamp goes. And yeah, this comes out very easily once you have that clamp open again. So it seems like all of our wheels, again, moving forward, are going to have this interface sticking out of it. I'm not sure what it's going to look like. If the collars are going to be on here like this, I would imagine it had to be something like that, because you're going to have some room also to clear the rest of the wheelbase housing here once we have our steering wheel on here. So that's also something to consider. All right, so it is plastic. It's a very stiff plastic, as you saw, and it even sounds like metal when you hit it. But we've got plastic in here, and this is, again, probably one of the stiffest wheels currently that Thrustmaster has because of the reinforced spider that's all aluminum and attached to this aluminum also. So it's probably the best case scenario currently that we have for a Thrustmaster wheel to test on this particular wheelbase. All right, so now what we'll do is go over to our mounting segment. I wanted to do a short segment on the inherent flex in the wheels from Thrustmaster, because I talked about this in the live tuning session as far as when I was handling the wheel and the flex that we were getting out of it. And I wanted to do a closer look, if you will, of that situation. Now remember, before this T818 and the torque that it can put out, we had all kinds of wheelbases that had less torque than this. And these wheel quick release systems were actually designed for that, not designed for this. And that's why moving forward, Thrustmaster says that they're all going to have this type of attachment on it. And they're going to be using this new fiber impregnated nylon equipment, including the insert here on this collar. And this is really stiff stuff compared to what we see on the hubs here on the threaded hub part. And when I was talking about the new quick release segment that I've done also, and this will probably follow right after that when I actually get the video edited out, that I thought this would be the stiffer of the two between the Ferrari 488 wheel here and this one, because there is a aluminum insert here. And this aluminum insert is attached to a spider that comes off to the left and right and supports the wheel's mounting points here. We have 3 on this side, 3 on that side. And this plastic hub is mounted into that assembly underneath. So I thought it was some kind of a reinforcement around this that would minimize the flex. When we look at the other wheel, it's plastic and it's plastic inside, and that's how its threaded hub is mounted. But as it turns out, this one actually flexes a little less than the SF1000. Yeah, it was a little surprising to me. And of course, when I did the review on this and you saw that spider that's internal to this wheel, I never touched anything in there on that because I didn't need to give you the information you needed on my look inside segments, right? So no need to mess with any of this stuff. So it's all factory stock when it comes to that mount, as is with this one, even though I did a look inside with this wheel. I normally never touch the mounting hubs that are attached to the wheels unless there's a specific reason I need to, right? In this case, we didn't have to do that. But anyway, I'm going to show you some video here. First, we'll do the SF1000. We'll do it from 2 different zooms. One will be zoomed out a little bit so we can see the actual hub that goes into the T818, and that's clamped down, and we can also see everything attached like it should be. And you can see, now I am putting some force on this, don't get me wrong. I am muscling it a little bit to get it to move as much as I'm making it move. But you can see that the majority of the flex occurring here is in the hub that's attached to the steering wheel. So it's internal mounting, as you can see it moving there. Now I'll pull away on the SF1000 so you can see the whole assembly. And now we're looking at, yeah, you can still see the steering wheel is moving, but not so much the quick release assembly. The new assembly and the materials they're using there are showing its stiffness in relation to what they've been using in the past. And it really shows here, doesn't it? I also did that with this Ferrari 488 wheel. We'll do the close-up and then we'll pull back. You can see in the close-up it's moving also. And once we actually do the pullback and show you the quick release system attached, or the hub that's attached to the T818, then yeah, you can see that it's really the steering wheel that's doing the flexing here. And my mount's also flexing too. If you watch close enough, you can see the actual whole wheel motor is going up and down too, because the mount's doing some flexing too. So there's a little bit of flex everywhere there, isn't there? But I wanted to do this segment just to show you guys that moving forward, Thrustmaster tells me that this is all going to be different, how they're attaching in the materials used on the hub part that attaches internally to their wheels, which is a very good idea, as we can see. Right, so that's what I do here at the SRG. I just show you guys everything I possibly can, let you make up your own mind about what you think about it. So let's take a look inside of this T818 direct drive motor. First off, I'll just go backwards on how I took everything apart. I started with pulling this front bezel piece off, and this is where the LEDs are located. You can see there's the plastic piece in there, right, that goes around. We saw that if you've been watching the video so far. You may not have seen it yet. It depends on where I put this segment in when I do my final edit. Anyway, you can see that plastic is also there. You can see through there, and each one of these circles is covering an LED. So we're having the LEDs encircled here to direct the beam and focus it on that plastic strip that goes all the way around the bezel. And it's just injection molded plastic, as you would expect here. This grill is not, there's no holes, or I don't see anything in there to aid in any ventilation as far as the other side either. So it's more of a decoration than anything else. The back bezel, again, injection molded plastic, and not much to see here, obviously, just the standoffs where we attach it using our screws. And we'll go over here and look at the case sides. Now here we can see on the inside that there's some ventilation. You can actually see the air through there, right? See my blue pad behind there. So it will ventilate. Again, it's like I said, if there's no fan in here, it's a convection type of ventilation. In other words, the cooler air will rise up from these vents. And of course, we have them on both sides. We even have some vents cut into the sides here. You can see I'm sticking through there. which also can help facilitate the cooling flow or the convection flow of colder air coming in the bottom as the hot air comes out the top. And the top is here. And again, these are our mode buttons with the Molex plug that attaches to the circuit board. We'll see in a minute. And you can see on the top, we also have vented holes. And this piece fits on the top. And it's the same thing. It acts like a vent on this section only. But the motor, as you can see here, and we'll look closer at that in a minute, is a thinner motor, the way this is shaped. So that's why you see the ventilation is only towards the front of the casements on the sides here. Now you can pull this piece off. This is replaceable too if something goes wrong with the switch. There's little snap tabs in here. I got them here, 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 all around there, and it will actually come out in case it needs to be replaced. And we do have some inserts here, by the way, some brass inserts for those covers that we talked about. So if you want to switch the color case, this is a machined insert. So it's a machine thread. All right, the front part that I took off the motor, this is where the LEDs are. Forget the orientation of this, but I'll figure out when I put it back on. I think it's this way because we have the number 1 right here on the plastic. And you can see all of the LEDs go around here. There is a plug that comes in and plugs into here from the circuit board. In fact, I think it's not that one, it's this one right here. You can see that wire running through there. That's what that's for. So we connect it to our LED and it runs to the back to the circuit board. And again, the LEDs, you can see it's the same thing as we saw in that front bezel. There's 4 on each one of these sides, and there's holes, obviously, corresponding to those on the front bezel. All right, let's go ahead and put this back so I don't lose anything. Now we'll take a look at the circuit board. And as you might expect, this is a nice, professionally laid out circuit board here from Thrustmaster. And yet, it looks like a thick board too. It doesn't look like a thin one. It looks pretty sturdy when I was messing with it. We've got our inputs back here where we can put in our pedals. And this is where the USB-C plug is. And this is where the power comes in from the power supply. We have our power switch here. So our power comes in here, and it goes in and starts feeding this power circuit up here that's going to give the power to the motor itself. What I like is this. There's actually a fuse in here. So if things go wrong, it's going to blow the fuse before it blows all other components on here that you might not want to have blown up. It's easier to just replace a fuse if something happens. If we have a power surge or something like that, you can actually come in here and see if this fuse is blown or not. That's a nice touch to a circuit board. You don't see that very often on circuit boards these days. Usually something just fries, a transistor or something that just blows up or fries or burns out, or a capacitor or something like that. As we come in here, so we know this is 10 amps, any more than 10 amps, that's going to blow. Then we have our power circuit here. Then we have our big capacitors and the usual suspects here. We've got some surface mount capacitors. We've got some inductors in here, as you can see here and here. We've got our littler capacitors supporting those power circuits. And then, of course, we're going to step it up with some transistors, diodes, and things. And these are the big capacitors that are going to go over here and feed this circuit. And you can see these big diodes sitting up here, power diodes. And this is going to feed the plug here. And that turns it into a 3-phase electrical wire. So it goes into our motor. Yep. I have to say, this is a good-looking circuit board here. I don't have any complaints about that. I don't think anybody would. It looks pretty well laid out, and obviously it's manufactured very well. Let's see. Now we're going to look at the back of the motor before we actually get to the motor. This comes off the back, and it sits like this. That's the bottom. And there's a plug there, obviously, that will plug into here and then go over to our circuit board that you just saw over there. And this is the position sensor, right? Rotation speed, position of the motor shaft, all that's calculated. This is part of that system. And we flip it over. It's kind of unique the way they've done this. How this is going to show up, try to get the lights to light it up. But we've got separate traces here that are winding around and stopping in different places. You can see where they terminate there with these little points here, 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 and here, and here. They all start over here. So there's different junctions here where these come in at. And this is the main one there. Probably not going to show up well in the video, but this is where a lot of the traces are starting in here. It's just an interesting design, the way they've set this up. And of course, we have all the traces coming back over here. As this motor is turning, let's go ahead and put this down. the sensor is back here attached to the rotor. As you can see, it's turning there. And of course, we have our connector for that goes to the circuit board sticking out. And as that shaft is turning, this sensor is turning in here, but it's also this plate is turning. So this plate is also engaging that board. It doesn't look like it's riding on it, so it has to be some kind of a inductive type of connection there, I would imagine. Could be wrong, but this is what it looks like to me, because obviously you're not going to be contacting the circuit board, or you'd rub those traces right off pretty quickly, I imagine. So yeah, some kind of inductive way, and that's why it's maybe wound like this. Interesting design. It's the first time I've seen that as far as a position sensing solution. I think that's pretty cool. Yeah, so that's attached to the rotor, and we have a typical in-runner motor here. That's what they're using. I could have pulled this off, but then that means taking the position sensor off, and then I'll have to figure out a way to, whatever it takes to recalibrate this probably. So I'm just trying to not doing that. Plus, all you're going to do, if we did that, we could see this, what's going on right here anyway. We know the rotor is in here, and the magnets are attached to the rotor, right, and around that. Here is the stator poles, and you can see each pole is wrapped. At least we can see 3 of them in there. That one there on the top, and then we got the 2 on the side. And that goes all the way around, obviously, on the whole motor. So we're going to use the electrical 3-phase, and you can see our big 3 wires coming off the board and going into the motor there to feed the motor. And of course, that's going to give us our power and move the motor where it needs to be based on the information on the telemetry stream coming in the game and where this is located at that time. And of course, how much power we're putting into it also. The motor is attached to a piece of metal here, metal flange. And this is the bottom of the flange right here. This clamp keeps shaking and rattling around. It makes me think I dropped a screw inside the motor or something every time that it does that to me. All right, so yeah, there we have it's kind of a stiff, it doesn't move at all. It's attached in the front by 4, and it's also attached in the bottom down here on another flange that is metal that's attached down there on the bottom. You can see those 2 screws there attaching it. Now, the motor casement itself is actually a nylon fiber reinforced product or material. Now, this is not the first time I've seen this. There's other motors that you're using right now from major brands that are made the exact same way. They have this nylon type of glass and carbon, whatever it is they're impregnating with this to increase the strength of it. So apparently that's strong enough. And we have a big bearing in here, big seal bearing in the front. It's going to be hard to see that, but let's see if I can get some light in there. You can see it. As everything's rotating on, of course, there's going to be another bearing on the rear here. So the shaft rotates very smoothly, and it does. But yeah, no metal here, right? So this is stiff stuff. It looks like to me, and I put it under my magnifying glass and was looking at it, and it looks like the same stuff that this is made out of. And I've showed you that in the closer look when I was looking at this, and I put it under my electronics microscope I use for my electronic stuff. And yeah, and it actually sounds like metal, doesn't it? So it looks like this exact same material in here. Interesting where we've gotten with the nylons and reinforced nylon materials now that we're actually using them in a motor casement. Yeah, pretty amazing actually. All right, so yeah, I can't find any fault with anything here as far as the way this is made. 10 newton meters constant torque might be, again, we don't know what the torque is as far as peak. I don't have any information on that. But this steel plate seems to do a pretty good job. In fact, if you watch when I'm driving in other segments of this review, you can see that I'm putting force on the wheel and it's actually pulling my motor mount. And it's a 10 millimeter thick piece of 6061 aluminum. It's actually bending that. So that's a good enough attachment, I would think, for this kind of torque in a motor. All right, so I guess that's about it. I think we've seen everything I can show you. So what we'll do is get on to the next segment. Now let's take a look at the different mounting options we have with the new T818. Now, as I discussed in the closer look segment, there is a new bolt pattern that Thrustmaster is using that I haven't used before. So the old patterns, like if you have a wheel deck that has something for a Thrustmaster, this will not fit. Now, the reason they've done this, of course, is the way this case is shaped and maybe the way the motor is shaped internally here and how everything's working. But we do have these 4 metal tabs sticking on the bottom here, or sticking out of the plastic on the bottom. I'm pretty sure that's part of the internal metal structure that attaches to the motor, maybe the electronics package, things like that. But anyway, this is a new pattern, and it is a 79 millimeter center to center this way, and it's 63 millimeters this way. So if you have a wheel deck with a Thrustmaster pattern on it, this will not fit it out of the box. You're going to have to get an adapter or a mount that they're going to be selling as accessories. Now, if you have a wheel deck like I'm going to be using, you'll be using a cockpit mount. At least that's what they call it. And basically what that does is convert this pattern by bolting it to the bottom of the wheelbase to a pattern that is the old Thrustmaster pattern as far as the width goes. I don't have that, so I'm going to have to do my own thing. We'll talk about that in a minute. Now, they also have what they call their desk clamp mount, and that is a metal mount. You remember, most of them were, I think they were all plastic before on all the other Thrustmaster wheelbases. But this is a metal unit. I'm showing you a picture here. It's got 2 clamps on either side, so that should be pretty sturdy, at least as sturdy as you can get on a wheel deck type of mount, or a clamp mount. As far as being all metal, that's always a plus. But they also have, again, the cockpit mount that's going to change the pattern. So those are the 2 mounts they have currently, and those are going to, I'm not sure what the price is going to be. They're going to be around $45 to $50 or something in that neighborhood. I'll get some pricing on the final thoughts probably straight on that. I don't have either one of those. So there's another option, obviously, is drill some holes that match this pattern, right? And of course, they do help you with that because they give you a PDF that you can download like this, and it has the bolt pattern on there. So again, 63 center to center this way, 79 this way. As you can see, I already have some holes cut in mine, and I've already used it. And it dialed in pretty easily. So all I did was tape this to my wheel deck, and I'll show you that in a second here. And of course, make my holes or mark my holes, and then I took it over to the drill press and drill out the holes in this deck. And I'll show you the deck I'm using here. This is from SimLab, and this is a pretty good deck as far as wheel decks go. It's all 10 millimeter thick 6061 aluminum. As you can see, it's almost looking like Swiss cheese these days because of the extra holes that I put in it for different mounts for different type of wheelbases I've used in the past. So you see right here, I don't know how well this is going to fit, so you can see it. If I can get the right holes here. There they are. Let me turn this sideways. So there's my holes lining up with the template. So now what I'm going to do, obviously, is put the wheelbase on top of here, and I'll run some M6 bolts from the bottom and attach it firmly to this. This is 10 millimeters thick again, and the wings are also 10 millimeters thick, but it's not the stiffest mount in the world because, well, it's, a piece of aluminum that's spanning 500 millimeters. And when you're going to be torquing back and forth on it, if you use a push-pull type of action on your steering wheel when you are racing, you might get a little flex in here, depending on the wheel that you're using, obviously, or how much force you have, things like that. I don't think this is going to be any problem. I'm probably not going to see maybe a little teeny flex, but we'll look at the video and see how that all washes out once we're actually using it. But we've got our holes drilled now. So again, matter of getting my bolts on, getting this mounted here, and then I'm going to take it over to the rig. We'll get it all mounted up, and we come back. We'll take a look at it and see how all that went. So the wheel is securely mounted to our deck, and you can see the electronics are working fine. And if we go over here, we can see it's mounted to this 10 millimeter thick plate that spans 500 millimeters. So not the stiffest mount, obviously, but 10 newton meters plus whatever the peak is on this should be fine. And you can see I have it secured after I cut that pattern in this plate with these 4 M6 bolts. The quick release system works great. Very easy to use with this clamp system to get it on and off. If you had 2 of these wheels with that system on it, yeah, just as quick as any other quick release system I'm currently using. So it all looks good. Everything is working. And what we'll do next is get in and check out what the driver looks like with this T818 wheelbase. Now we have the wheel attached. Everything seems to be working. It did its boot up process, and I'll show you a shot of it there where it turns like 90 degrees to the right and then comes back. So everything worked fine there. What we're going to do now is go ahead and we've already selected the Thrustmaster Advanced Mode Racer. We're going to go to Properties, and that should bring our driver screen up, and it does. And that's what it looks like. Get it over here, make sure I got enough room for my wheel. And this is where we can see what the wheel is doing, and it looks like it's behaving as it should. And we can also see it identifies the T818 direct drive wheelbase. Firmware is currently 5.12. The CAN firmware is 2.11. And the CAN firmware is the firmware in the adapter that allows us to connect this to the wheelbase. And I did a little segment on the new quick release and how it works. You want to make sure you get that adapter seated all the way in as far as you can into the wheel that you're going to be using, because you want to make sure you have good electrical connection. I didn't have any problems after I connected it in, as you saw in that segment. So it never had a glitch so far. Everything's working like it should, which is a good thing. I kind of wonder about the new wheelbases and wheels that come out and how well they're going to work. So everything's working great here. We would test our buttons here too. And if you notice, when I went into the driver, the screen changed from the default screen to the screens that we're going to be using in the display, depending on what screens we're on. So all that's working too. Yeah, let's go ahead and test the shifters are working. Yeah, my lights are lighting up. Clutches are working. My clutch selector down here is working as far as the, not really a clutch selector, but it's an analog axis selector. Buttons, let's see, bottom encoders are working. Yeah, they're working good. Thumb encoders are good. So yeah, everything's working as it should. We can move on to what we really want to see here is the gain settings. And right now it's unlocked. I'm going to go ahead and lock it back because I've been messing around with this. And then when you lock it, the max you can get is 70% on the gain. But then when you unlock it, a screen will pop up and tell you that be careful. This is a serious torque that this wheel can put out, and yeah, make sure that you know what you're doing, kind of thing. So I think I know what I'm doing. Sometimes I don't, though. So we'll put it at 100%. Default also is 10% on the gain, or rather not the gain, but the damper. We have 4 modes here. We have comfort, sport, performance, and extreme. I'm going to go with extreme, and we can test our force feedback. Actually, I'm going to go, let me try to sport the force feedback and see if it's the same as it is for extreme, just for checking basic things here. Yeah, that's not too heavy. Let's go ahead and put it on extreme and see if that takes it up a notch. It may or may not do that, I don't know. So here we go. Grab it with both hands here. Oh yeah. Yeah, she took off then. So yeah, this has some torque in it, no doubt. And we know we have 10 newton meters, what is constant torque, as the Thrustmaster marketing material calls it. We don't know what the peak is, but you know, we'll see how that works once we're in game. So the other thing we're going to do here is LED settings, and we can change our colors. I think currently where I'm at, kind of a red here. So, or a pale red. Let me go over. Yeah, we can change color. You can see it's changing color, green, red. I'm going to go all the way back over to red. It seems to be a brighter red on that side. Yellow, green. So this is where you choose that stuff. So you want to play around with your colors, and there's different intensities of it over here. Apparently we move that slider, things change. Anyway. I'm not that concerned with the colors really, because especially with this wheel, I can't even see what the color is until I've turned it this way. All right. One more thing down the bottom here. It says that you close this by clicking OK, which is obviously how you close this down. I'm going to leave it open, and it says before starting the game, you should close it. It doesn't really say that, but I'm thinking that you can leave this up. And while we're in game, we should be able to go in here and change some of these settings around, like from extreme to sport or performance, and I can see what the differences are. So I'm going to try to leave this open when I start the game and see if that actually takes effect while we're in game. All right. Now, one more thing about this, I wanted for the last thing, because it will cut the wheel off, is I wanted to show you the button over here, which is the force feedback kill button. Now, if this wheel, if this wheel took off on me and I couldn't hold it and start spinning around or something, I could get my hands away from it and reach around pretty easily over here and push this button. And when you do that, you can see it starts flashing red. Now what that means is the motor is not putting out any torque anymore. However, the motor is still active. The location of the wheel is still active, which means you should be able to continue your race. So hopefully that works that way. I'm going to test that once I'm in a game. But the only thing is, to get rid of it, you have to go around the back and turn it off. You can't do that in game, obviously. That's the end of your race, right? But you can race on without force feedback this way, I suppose, if something you wreck or crash and something went crazy with the force feedback. So we'll go ahead and start it again, and we'll see the startup sequence. it still wants to take it all the way over to the right at 90 degrees. It seems like that's the point where it's sensing the calibration where it needs to be, and it always turns it back to center. So we're good to go there. And you can see my dashes did not come back up. That's because this is still open. And if I click OK and close that down, then go over here to Properties, select it again, Properties. Let's see, yep, my dashes come back. So I'm thinking you can leave this open, but we're going to find out once we're in game. And we'll leave our gain settings available so I can play around with things in here. And of course, in game, whatever game it is that you're running, you'll be able to mess around the settings there. And you can see our force feedback is, well, it was back until it's a very sensitive little button there. I mean, I just barely touched it. But yeah, that's probably a good thing. You don't really have to press on it. And we'll go ahead and do another startup real quick. You can see it goes to the same position every time before it comes back. Now we're good. Okay. So I'm going to leave this open, and then what we'll do is get in game and do a little live tuning session and, yeah, see what we can do. Okay, guys, we're going to get in and do some testing here on a live session. My current settings are 100% for overall strength, 10% damper, and that's default. I'm going to go ahead and go with extreme out of the comfort, sport, performance, and extreme choices. And I'm going to go through these. What I'll probably do is go through these first and see what the differences are. Yeah, just make my comments as we go along here. So let's go ahead and get in the car. All right, so let's go out on the track and see what it feels like on the stock setup here. You won't be able to hear the car much because I have it turned down a lot, but just enough for me to hear it, because I just can't drive a car without noise, hearing what the engine's doing. All right, so my settings in iRacing are set up for 10 Newton meters, and that's a constant on this, so I'm going to leave it at that. Other than that, we're at default. And yeah, it's got some power, no doubt about it. The connector, being plastic the way it is going to have a softening or damping effect on what the wheel can do. And I'm going to be showing periodically what the wheel is doing as I'm driving it. But right now, just going from back and forth, I had to say the first thing I noticed about this wheel is it's very smooth around the center. Now, a lot of servo motor wheels, when we first get them out of the box, they have a notchiness around the center. And it's hard to describe if you've never felt that before. So in other words, the notchiness is when we're turning from one way, or left or right or left, whichever the case may be. And this doesn't seem to have that. It just kind of rolls. And this is extreme, as much power as I can get out of it. The clipping on this is, let's hit some bumps here. Yeah, I got it so when it comes off the bumps, it's at yellow. And this is using the iRacing clipping meter for force feedback. So it's about where I want it. But there is some, it still feels like there's something more there to the track than normally when I'm turning it. Like some kind of a road surface irregularities. But yeah, you can feel it when it starts losing grip, so that's good. And it's definitely giving me some good detail, which is a little bit surprising because I didn't think it would as much, being the plastic we have, even though it's a stiff plastic, in our hub assembly here attaching to the motor shaft itself. All right, so I'm going to take this down to, let's just go down a notch at a time and see if there's a difference, or an obvious difference anyway, on what we're feeling. And I think there is straight away. Now, the way all my buttons and everything are working as they should. You see down here, my little menus are going back and forth. Let's go ahead down through turn 17 here. Yeah, it's not quite. In fact, I might prefer it at performance. It's not quite as sharp. It was almost a little bit too sharp, if that's possible, in force feedback when I'm in the extreme at 100%. and only 10% damping. We could probably fix that in extreme with damping. In fact, that's what I believe this is doing. It's throwing more damping on it. But we're still getting good bumps through those turns. You can see I'm grabbing the wheel, and I'm fighting the wheel through it as it's hitting those bumps. Turn 1 is a very good example of that to test on. Let's go over some curbing, yeah. You can feel the wheel angle change as it rolls up the curbing and wants to go one way or the other, depending on which way we're going over that curbing. Because when you go up the curbing, there's a little bit of a ramp there, and usually you can feel the steering wheel wanting to turn at that point. Actually, performance is feeling pretty good. It's still very smooth around center, and that's one of my big things. You know, not everybody cares about that, but it just seems more natural or analogish to me when you have smoothness around the center of the wheel when you're steering. Transitions, yep, good transitions across the concrete patch. Good transition there. Seems to be doing a pretty good job for what it is. You know, it's only 10 Newton meter constant here. I'm not sure what the peak is, like I keep saying throughout this review. I'm not sure what that is, but yeah, performance is doing pretty good. I'm a little surprised here. Good rumbles. I don't know if you can see that rumble there. Now what I'm going to do is, I like that actually, but I think I might be able to go back into extreme and get the same thing by increasing the damping. Because it says it changes the reactivity and damper, which that's exactly what it's doing. So it's a bit of a filter, if you will. Even though they say it's not filtered, well, this is filtering what we're doing here. But you need this to be able to get the wheel where you want it to be, as far as feel. Yeah, and right away I can tell a difference there. This is Sport, which might be a good starting point for most people. It still gets a pretty good sharp hit off that curbing there. Let's go over this. When you transition over this strip and then back on, there's a real sharp hit there. There's good rumble there. Good rumble through here. Again, everything's been turned down because we went from the performance mode. Let's go ahead through turn 17 again in Sport. Yeah, that's a little bit soft for me, but you still feel the bumps going down the straight here, and we're going to feel them, I'm sure, going through turn 1. Yeah, that's pretty good. It holds good torque through the turns. I think the firmware has been tuned well there, because there are some wheels, especially out of the box, that when you're going through a turn, at first you feel the force of the turn, but it doesn't feel like it's holding it all the way through. It's hard to explain. It just feels a little different once your suspension is set in the turn. It seems to come off a little bit as far as how much force you're feeling against you as you're trying to keep the wheel pointed into the turn. All right, let's go through. Even slow, it feels like you're really rolling over things. The timing is good. It doesn't feel like it's delayed or anything. It's on time. We're going to go down to comfort now. 10% damping, 100% effects. Let's see what that does. Very gentle, almost smooth swooshing going on now as far as the track feels. Some of the texture of the track is gone now. Yeah. But still, through the turns, as you keep it turned, it remains a good force that you're fighting in the turn as far as the wheel wanting to come back the other way. Return spring, if you will. But it's smooth. And that's the big thing that I like about this so far, is it's a smooth wheel. It doesn't have that notchiness that a lot of servo motors have out of the box. You can tune that out to a certain extent depending on which wheelbase you have, obviously. Let me go over here. Yeah, still the bump there, but it's just everything is smoothed off. The little spikes off that wave are being trimmed off. And this is, yeah, the bumps are pretty soft there too. So Comfort might be something good to start at if you want to go 100%. But what I'm going to do is see if I can get, I'm going to go back to extreme. And I'm going to dial that up to, it was 10, let's go 30. Because I think we're going to have to dial in some for the extreme. In fact, the extreme, as soon as I start turning the wheel, I feel it's very sensitive to the road surface. And as you turn, there's a rumble to it. As we're in the turn, it's actually turning. And going straight, there is none. And when I'm transitioning back and forth across the center, it's smooth right at the center, but there's this, it's like a rumble. It's almost like it's too sensitive. So let me take it back. Let me get 50% on this. Can we do 50? There we go. Let's see if that helps. That helps a little bit right away. I can feel it. Yeah, but there's still a lot more power in the wheel. It's at full power, obviously. At extreme, they've got it turned all the way up. It's almost, the wheels, you can see it. I don't know if you can see it in the video, but it's really jumping on the bumps a lot. It's really, I don't know if you see it shaking the way it is, but it's really intense, which is not what I like. And I've got 50% damping in it already. I'm thinking extreme. Let's take it up to 70. Of course, we're probably getting diminishing returns now with the damping, but we'll see. I mean, if you have to have that much damping, then you probably need to do something else. Yeah, it's just too something, too sharp. You can feel the plastic connection here with it turned up like this on the extreme. Now, what I mean by that is you can feel the sharpness of it, but you know it could be sharper if we had a solid metal connection to the motor shaft on this particular motor. And it's just softer because of the plastic. If you see, I can actually move this around a little bit. You can see right there it's moving. And I got some side shots, I'll be showing you that too. But yeah, I can actually cant this sideways. So if you're pushing on the wheel like I do when I turn, I can feel some flex in there. Certainly is, and I expected as much. Even though they have a some kind of fiber reinforced nylon going on here with their connections, I can feel that flex. And of course, that's a damping effect. If it was metal to metal, it would be even more intense. It's probably going to oscillate. Yeah, see? Okay. So it does oscillate. Let's see if I can get back on the track here. Sliding all around. Grass is not good for traction. All right, so I'll just go in here on the braking and see how it oscillates. And I get some control while it's under braking. Oh, that's not bad. Well, it started to there. Well, let's see. We do have 70% damping on it now. Probably do it more if I had less. But yeah, the road surface really is coming in too much on this. Glad it is not metal because it would be intolerable. Or intolerable. Yeah. I think extremes, even with 70% damping, I'm not liking it very much. It's just too intense, and it has the power in it, causes you to put enough force in it to counter what it's doing, right? So you can steer the car, that you can feel the flex more in this attachment system that they have here. Yeah. So anyway, I'm going to go back to performance, leave it at 10%, and I think that's where I was happiest before. Remember, there's not a lot of adjustment here. There is some adjustment in game, depending on the game that you're running. Yeah, the performance right away is smoother. Hit this bump. That's a good sharp bump there. This is kind of smooth here. But remember, coming off of this piece right here, this rumble strip coming back on the track, it's really sharp there. Yeah, this is probably where I would want to be here. Good rumbles across there. But again, I'd like to see a little bit more sharpness in those rumbles. What if I took some damping off of this? Let's take it down to 5. Well, it's either 0 or 10. Oh, there we go. We can do 5. Well, let's do this. Oh, there it is. No, 6. Let's make it 5. All right, so that's half of what we had before. So it took some damping off. Again, very smooth around center on performance, which gives it that real life analog feel for me anyway. Get this back in here. All right. Yeah, this is very smooth going down the road. It's like the Extreme is just a little bit over-tuned, a little bit too much sharpness. They're not notching off just quite enough of the peaks of that force feedback telemetry wave that's coming in. Yeah, good control down here. All the bumps, you can feel these very good. Going through turn 1 here, it's going to be a lot of bumps going on. Yeah. You get a good feel for slip angle as far as when you start losing traction. Let's get out of here quick. Yeah. I didn't catch it, but I could feel it slipping right away. Second gear is easier to get out of the grass. All right. I think I'm settling on what I would use if I was using this wheel all the time. By the way, the steering wheel, as far as the connection goes, everything's working fine, just like it should. No glitches, no hiccups. I've got a few hours on this now. The motor itself, I've been testing that for heat, and it's not getting hot, even when I was running an Extreme. Of course, maybe an hour session would be warmer then. Of course, ambient temperature also matters on any motor, on how it's going to behave as far as temperature goes. Yeah, I think this is, that's a hard bump right there. In fact, that bump will throw you off on that curbing there if you're not careful. Yeah, it's giving me enough information, or plenty of information actually, to be able to control the car like I normally would want to through that section. I'm going to take it one more. This time we're going to take it at speed through turn 17 here and see what we get. Yeah, I think the 5% is going to do it for me here. Still, I would rather have seen them gone with a real aluminum, I think, on this quick release system they have. Because there is some softness at the highest levels of angular attack that you're putting on the steering wheel. I can feel that softness in it when I'm doing some of my turns. Not slow turns like this, but once you get into the high-speed turns. Good transitions, by the way. All the bumps are good, on time, right on time there. That's a very good transition on the concrete patches. So good textures. I think they've done a pretty good job here, right out of the box. I mean, normally, you know, when a wheel first comes out, there's a lot more tuning that is going into different firmware patches as they deliver the wheels out to the general public, and everybody starts using it and complaining about what they can and can't do, or what they want to feel with the wheel, and they start, you know, fine-tuning the firmware, taking those suggestions and doing something with them. This is not bad, I think. You know, it's just that the flex part of it. You can see when I'm turning, I'm pushing my hand here, and it's noticeable. I think, and the whole thing is it's plastic everywhere. You know, it's plastic on the hub that's attached to the actual steering wheel that I'm using, this SF1000. It's plastic as far as the insert goes. Stiff plastic, mind you, but it's still plastic at the end of the day. and it's plastic on the hub part on the motor as far as I can tell. And I checked that too, and it was definitely not aluminum under there. I'll be curious to see what we see once we get to the look inside of what they've done as far as actually attaching that hub that goes on the motor shaft itself. But it feels good as far as the force feedback goes. I mean, they've done a pretty good job with this firmware. I'm a little surprised, actually. Of course, some of the damping, again, all this stuff is so subjective when it comes to how you want a car to feel and be able to handle it correctly and turn consistent laps with it. It becomes very predictable what you're feeling, what that means, and what you need to do as far as counter steer to correct any errors. So they've done a good job with that, and it's good around center. I really like the center on this because it feels, well, just like the center should feel, at least I think, on the servo motor system that I use on a daily basis. I hate notchiness around the center. It just doesn't feel natural at all. It just feels digital. I mean, that's all there is to it. You get in a real car, you're not going to feel that. So I would like to know what the peak is on this when we're rolling over bumps and things like that, like when we're hitting these bumps and coming off the side, because it's a pretty good hit that we're getting when we come off of there. So if it's 10 Newton meter constant, I could only guess what the peak is. I know when I was doing the closer look, I saw that the T818 and a dash with 16 on it. I say, oh, maybe that's 16 Newton meters peak. But of course, obviously, there's no way for me to be able to verify that. So could be just the 16th wheel that they made and sent it to me for review. All right, so I'm pretty happy, really. I'm a little surprised here that it feels as good as it does. I'm not happy about the flex that's in the system itself, but that's not the firmware issue, right? This is the actual construction of the wheel, and there is some oscillating. You can see that, and I've only got 5% damping on it. I wonder if just as a quick test here, I'm pretty happy with what I got here, because as long as your hands on the wheels, as you saw, it doesn't oscillate. Holding it this much, it doesn't oscillate. And I've always said that it doesn't matter to me if it oscillates. Obviously, if it's a severe oscillation, it does matter, but it doesn't matter. I'm going to put like 50 on here. Well, 49 is close enough. I don't care if it's oscillating because I don't take my hands off the wheels when I'm racing. I don't know who does that, but you know, it doesn't matter to me. So let's go ahead and do that braking, and yeah, it's less oscillation now, as you can see. I'm trying to induce it, and that makes sense because we've turned the damper filter up. So it's not oscillating as much. And I just felt it slip there and caught it. It doesn't, some of the detail's gone, but then that's always the dance we play with these direct drive wheelbases. Detail versus damping. How much smoothness you want out of it, how much sharpness you want. And sometimes you can find a happy spot, and sometimes you cannot. So far, this is not as bad as I thought it would be at 50%. Yeah, okay. So I think we'll just go ahead and end it here. I think I found what I wanted as far as me driving this wheel. I think they've done a good job with the firmware on the initial release here, and I'm sure they'll be making some changes as we go along in the future. So we'll go ahead and go on to the next segment. We're starting out in iRacing at Sebring, and this is the new Sebring track from iRacing, the updated one, in the Ferrari 488 GT3 Legacy car, my normal baseline testing setup here. So the first thing that impressed me about this wheel is the smoothness around the center of the wheel when you're turning it left to right. Most wheels, and just about all of them that I've gotten in the past, no matter what the manufacturer was, at these kind of torque levels, they had some notchiness around center. And it gives you a kind of a digital feel to, or an unnatural feel to the steering wheel. Once you have a wheel that doesn't do that, you'll know exactly what I mean. It just doesn't feel like it's a real wheel, or can even get to there. But the firmware packages have been updated on other wheels. I'm sure they're improving that, but this out of the box, they did a good job with this firmware. I was surprised, actually. I was expecting, you know, some notchiness and the normal stuff that I feel on these new wheels when they come out. Now, Thrustmaster did take a long time to come out with their T818, so I suppose that they were in there tweaking the firmware a lot. So anyway, I'm happy with the center on the wheel. Now, it has 4 modes. It has the Comfort, the Sport, the Performance, and Extreme. All but the Extreme felt pretty analogish to me. The Extreme, unfortunately, had some... It was just like it was a little turned up a little bit too much. Not like it was clipping, but it was just... Everything was just too much, it seemed like. Even when I put the damping up to 50 and 70%, it just kept feeling like it more digital than it was an analog. Now, once I could actually take the gain slider and slide that down and take some power out of it. But at this point, we're getting down to performance mode, right? And we got all that gain, or rather, we had all the damping put into it already. So I found the sweet spot in the performance mode is what I'm getting at. Both for iRacing and for Assetto Corsa Competizione, which, you know, is not my favorite game as far as force feedback. I know a lot of people love it. I just can't get to sorts with it. I don't know, something about it just feels not connected as much. Although they have great effects in Assetto Corsa as far as the rumble strips and things like that. It's just when I'm on the road, I don't feel like I'm totally connected to the road surface like I do in other games. Even though the refresh rate on their force feedback is better than iRacing. It's like 400, something like that. But I was able to, obviously, to get it set up right and control the car and make some good consistent laps. I'm always able to do that anyway. And the wheel did good there. Again, performance mode is what I used it in. Everything worked as far as electrical connections with that quick release adapter. I didn't have any problems with that, but I did take care to make sure I had it seated properly before I installed it, and everything worked fine. I never had any issues with anything. The quick release system, that's where this falls down for me. It's plastic, and plastic is plastic. Even though they have this really stiff plastic, this fiber reinforced nylon or something that they're using here, it does a good job as far as stiff as plastic can get. But it's still going to have some flex in it. Not as much as I anticipated. Most of the flex that I found in this wheel, and if you follow along in the live tuning session, you can see that flex. It's actually in the wheel itself. It's in the hub that is attached to the steering wheel that goes through that aluminum plate on the back of this SF1000. I could see, in fact, I had somebody else moving it for me, and I was watching there with a flashlight to see where most of the motion was coming from. That's where it was. It was pivoting or kind of moving back and forth where it goes into the aluminum plate on the steering wheel itself. Not so much in the quick release. And if you look at the tuning, you'll see that it's really in the steering wheel where the flex is. So hopefully moving forward, Thrustmaster is going to be using these plastics in their new quick release system that all wheels moving forward apparently are going to have this on it. So eventually the adapter thing is going to go away once all those wheels get old and nobody's using them, I guess. But again, I don't think it was really the adapter itself causing it. It was really the steering wheel itself. And that's just because of the way the steering wheel is made. And hopefully the plastics that they use are going to be the same type, the fiber reinforced nylons or whatever we have that you saw in the closer look. And yeah, so overall, I think the wheel, the firmware, and the motor deliver here. I really think it does. And I'm a little surprised at that. I was thinking, well, you know, it just doesn't feel like the normal servo motors I get from these low torque wheel systems. I'm curious once we get to the look inside what's in there. So what direction they went in as far as the electric motor goes. But the firmware feels like it's already mature right out of the box, which is something that you usually don't get. Usually manufacturers, you know, they got to get these things out the door to market to beat each other, that kind of thing. And they'll just keep updating and improving the firmware as they go along, as we've seen in the past. But they got a good start with this, I think, this wheel. Except for, you know, the quick release system being made out of plastic. I would rather see this be made out of metal, you know, aluminum, whatever, some kind of steel, just to tighten it up a bit. And the wheel itself, these wheels that they're making, they're going to have to consider that moving forward also. That, you know, a lot of guys are going to be bolting this on this T818. I'm sure this is going to be their flagship wheel base for a while. And I'm sure eventually it's going to have a mod or have some firmware that's going to talk to the PlayStations and the Xboxes so people can use them for that too. So I think they've got a good start here. Again, the quick release system, I'm not crazy about. Can't really say much more about that. I think I've said it all that I could. But yeah, at the end of the day, they've got a good motor here, I think, and the firmware driving it is good. So it's up to them to figure out the rest of it. So we'll go ahead and get on to the final thoughts. Final thoughts on the T818 direct drive force feedback wheelbase from the guys at Thrustmaster. Out of the box, the T818 presents as an entry-level direct drive solution. There's a lot of injection molded plastic used in the construction of the T818. Even the new quick release system is made of some type of fiber reinforced nylon, although the new material is noticeably stiffer than the nylon used in the wheel side connecting hubs Thrustmaster has used up till now. The motor is mounted to a steel plate assembly that does provide enough stiffness for mounting duties. The new quick release design is a welcome upgrade from the previous solution. It provides a true quick release function for their wheels, and because of the new stiffer material used in the construction, provides a noticeably stiffer driving experience. Of course, when you stiffen an area of a connection, it tends to reveal any previous weaknesses in the parts not upgraded, which can be seen when pushing the existing Thrustmaster steering wheels from side to side. Thrustmaster has said that all their new steering wheels will be using the new stiffer material in them, as well as using the new wheel side adapter design seen here. We will have to wait until they start shipping the new wheels to see how much of a difference it makes. The motor casement is made from another fiber reinforced nylon. This is not the first time I've seen this construction technique in an entry-level direct drive wheelbase. Some manufacturers actually use reinforced nylons in the actual motor shaft. Interesting to see how far we have come with the plastic technologies. The force feedback quality out of the box is quite good, I think. There's no notchiness or cogging around the center of the wheel when turning from left to right in all but the extreme force feedback modes. This gives the wheelbase a more analog feel than most other out-of-the-box experiences I've had with other direct drive solutions. A great start in the inevitable firmware evolution process for the T818. I did not notice any undesirable force feedback behavior except for that extreme mode setting, which gave me a feeling that the wheel power was being overdriven a bit, producing some notchiness and digital feeling artifacts. So I ran the wheel mostly in performance mode to get consistent lap times with a good feel for the control of the cars that were driven. My only real complaint for the T818 is that it shows that the nylon used in the Thrustmaster wheel hubs to date are not up to the task as far as stiffness is concerned. Hopefully they will be able to address this in the newly manufactured wheels coming in the future. I'm Barry Rowland. Thanks again for watching the Sim Racing Garage channel. Don't forget to hit the subscribe button. And if you would like to help support what I do here at the SRG, visit my website at simracinggarage.com.